Hi, I'm George. I'm co-founder and head of development at Opinum. Today I'm going to show you how to connect an IoT device in the platform, going from nothing to data usable in the platform using customization features and master data. For this demonstration, I will be using the following technology: LoRa and LoRaWAN, the Things network, and built-in features of Opinum Data Hub. I'm now going to let Rishab from the Things Industries introduce you with the Things network, LoRa and LoRaWAN.
Hi everyone, I'm Rish here from the Things Industries team, and in this video, just a short description about what we do and what are some of the services that we offer. So we, as the Things Industries, we offer commercial LoRaWAN services to a broad range of customers around the world. We're also a key contributor to the Things network ecosystem. We operate the global community network and also sponsor the open source distribution. Our main business model is software as a service, where we offer private LoRaWAN network, which comes with SLA and support. We also provide consulting services, custom integration services, and also do events. The Things Conference is one example, but we also curate a lot of local events in several cities around the world. With the Things Network, we help companies try the world of IoT. We help them go from 0 to 1. Whereas with the Things Industries, we provide them with the right tools, right platform, which reduces the risk of IoT projects. And we help them go from 0 to 1 million, 1 to 1 billion. And we do this by reducing the time that developers spend on IoT. We abstract the complexity out of IoT, prevent this by not having any vendor lock-ins, making sure the solution is scalable. So that's a short description about what we do. If you have any questions or need any help, feel free to contact me. I'm happy to help. Cheers.
Okay, thank you, Rishab. Now I would like to talk briefly about the hardware that I've used. The first thing that you will need if you want to do some LoRa and LoRaWAN application is a gateway. So this is a Dragino LG01. It's quite good because it's relatively cheap. It's an open source LoRa gateway. It's relatively easy to configure, but has one big downside, is that it's single channel and so no downlink is available. As an alternative, you could also use the new gateway made by the Things industry called the Things Indoor Gateway. It's an 8-channel LoRaWAN indoor gateway. It has very simple setup, taking less than 5 minutes, and it's also relatively cheap with a price tag of about €70. You will also need an end device, and in my case I chose the LoRa Radio Node V1. It's an AVR Arduino development board built around an RFM95 LoRa module. It's also relatively cheap, with about €15. It has a lot of documentation available online and has multiple interfaces like I2C, SPI, and analog inputs. To connect to that radio node, I've used a BME280, which is a simple temperature and humidity sensor that is communicating its data over I2C. For your device to be able to communicate with the Things network, it needs to be activated. The activation methods are the following: OTAA, over-the-air activation, which is the most recent activation mechanism, and that means that the device sends a join request to the Things network, and if the request is accepted, the Things network sends a join accept response. To be able to use this method, your gateway needs to be able to use downlinks. The problem is that in my setup, the gateway that I'm using doesn't accept this. So we can use the older version, which is activation by personalization. In this case, the device is preloaded with keys that allows it to communicate straight away without having to do the over-the-air activation. When you connect to the Things network console, you see the following landing page with the two main sections of the platform. The first one is applications, and the second one is the gateways. If we go to the gateways, we can see that I already prepared my gateway. There's nothing really fancy with this. The most important thing is the gateway key that you have to reference in the configuration of the gateway itself, and the frequency plan and router that you're going to use. In my case, I'm using the European frequency plan with 868 MHz and the TTN router EU. Okay, so now we can go back to the homepage of the console and go to the applications. You can see that I already have some applications, but for the sake of this demonstration, I'm going to create a new one, just by clicking the Add Application on top right corner. I'm going to name mine Opinum Demo Event. You can also add a description, which is not mandatory. An application EUI is going to be generated by the Things Network, and you can also select the handler registration, which in my case is TTN Handler EU because we're in Europe. Then click on Add Application. Right now you have a brand new application with no devices, with nothing. It's just completely empty. When your application has been created, the first thing you want to do is adding devices. You can click on the Device tab and then click on Register a new device. You have to give it a device ID. Doesn't really matter. We'll call it Demo Device. The device EUI can be provided either by you, or you can ask TTN to generate this for you. This is what we're going to do for now because it's simpler. Then you can click on Register. Once the device is registered, we have to go to the settings and activate the OBP activation mode, because the gateway we are using right now is not able to use the OTAA as I explained earlier. You can see that it added new keys here, and it is saying that those keys will be generated by the Things Network. Save this, and then you have your device ready. As I explained earlier, the device that we are going to be using is a LoRa radio node v1.0. This is an AVR Arduino development board, which means that we can program it using Arduino. To do so, we can go to the Arduino IDE, and we have all of the information here that we need to insert in order to configure the different keys that the device is going to need to communicate with the Things Network. We have all those keys at our disposal right in the console. You can see that there is a device address. You can copy it from this little button. If we go back there, it corresponds to the dev address that is here. And paste it. We also need the network session key and the app session key. Conveniently, the Things Network console allows you to display the information in a format that you can simply copy and paste in your Arduino code. So in this case, you can copy it. This is the network session key, so I can go to the network session key here, and then I will do the same for the app session key. Well, just like this, the device should be able to communicate. I can then compile and upload the code to the Arduino device. It's going to take a few seconds, but we can already go back to the device overview, and normally within this and a couple of seconds we should see the status changing and having the device saying that it's been seen by the Things Network and it's working properly. Okay, now it's done uploading the code to the device. So the device is going to try to join the Things Network, and when it's going to be ready, it will start sending data. See, now the status just changed, and the device is up and running, ready to be used in the Things Network. We can also see the data tab that is going to show the data that's been uploaded. In this case, the Arduino board is simply going to use the I2C protocol to read the BME 280 sensor that I connected to it and send information about temperature and humidity. This payload is what the device is actually sending, and as you can guess, it's not really easy to read. So we can go back to the application and use the payload format. The Things Network allows you to insert a custom function so you can take the payload sent by your device and transform it into something that is easier to read. I have prepared this function for this use case, which looks like this, and I can save my payload function. Now if I go back to the data tab, we see the previously sent data from the device, and as the device is sending one message every minute, within this and a few seconds we should be seeing another line, but this time this line will include the decoded data. Should be there anytime soon. And there we go. We now have the humidity and the temperature of the room. So we're almost done with the configuration in the Things Network. We can now jump to Opinum Data Hub. Once we go back to the Data Hub, the first thing we need to do is configure triggers. First trigger that we can configure now is a custom format trigger for the Things Network. We have an engine that is going to be able to get the data from the Things Network and transform it into data usable by Data Hub. It's actually going to transform this in the OPSEND standard format. Once you are in this step, you need to copy this URL that is going to be used in the Things Network. You can close this. Then you need also to create another trigger for the OPSEND standard format. And that is going to be uploaded in the storage. And because it's going to use a file produced by the other trigger, it needs to contain or start with, in this case, by mapforce preprocessed. So you can go back to the Things Network and go to the integrations. Within the integration, you can add a new integration, scroll to find the HTTP integration. Once you arrive in the integration page, we need to give it a process ID. It's a simple name that we can use. We're going to name it DH forward. The access key, which is an internal security thing from the Things Network. In this case, we can use the default key. The URL that we copied from Data Hub. It needs to be an HTTP post in our case. The authorization, we're going to use a simple basic authentication header. And you can even add a custom header, name and value, in case you need it. In our case, we don't. Then you can click on Add Integration. Right now, this means that each time a new data point is coming from the device, it's going to be sent to Data Hub. If we look now in Data Hub and go to the storage page, we can see that there is a new file that came, a new JSON file that came right now. So I can download this file and open it. Obviously, this is in the way. Okay. And This file is going to contain a hardware serial number. In most cases, you can find it straight away on the device that you are using, but in our case, I can just show you that the device hardware serial number is written here. So now we can copy this guy and go back to Data Hub. We are going to add a new source, a custom one. We are going to add it to a site, doesn't really matter. Give it a name. The source type is going to be a push data. And the only other information that is useful now is the serial number. The rest doesn't really matter. The energy type is required. I'm going to do temperature. Save. Now we can go to the sources and see the new source that we just created. And we need to create some new variables. First variable that we are going to create is temperature variable. The unit is going to be Celsius degree, and we know that we have one data point every minute, and it's an instantaneous data point. We can add another one for humidity, which is going to be in percentage. This is also going to be a 1 minute data point and an instantaneous information. But now, the most important part of creating the variable is setting a proper mapping config. Setting the mapping config is done using this little icon, and then in this field you add the name that you want. If you remember well, here we decided that we were going to use hum and temp, and if we look back at the data that we received from the Things network, it sent those two fields like this, hum and temp. And this is what the trigger that we configure is going to use for the mapping config, which means that we can now, for the temperature, use temp, and for the humidity, we just do HUM. And save this information. We're going to let the application and the Things network send data, but now we can add a new graphic, demo, which is going to be a time series, and we want to see today the raw data, and we want to add TTN demo device, temperature in Celsius degree. We want to keep it green. We will duplicate this one so we can take the humidity in percentage, and we both are going to use the line display. We need to set one of them on the secondary axis because it's not the same unit, and we're going to change the color. And now that everything has been properly configured, if I click on the save button, I should have, see, now I have data. You can see that I have like one data point that flowed in the application. And if we go back to the data, we can see that the data is slowly coming in because it's one data point every minute. We have seen that we can easily get the Things network to forward device data to Data Hub, and Data Hub to properly interpret and ingest the data. If you plan to deploy an IoT application, chances are that having to work with two distinct portals is going to be an issue. There is a very high risk of mistakes while copying the information from one side to the other, and automating this process is going to save you a lot of time. This is the reason why I would like to take this demonstration a bit further. The Things network has a great API that allows you to manage applications and devices very easily, and the Opinum Data Hub comes with built-in features that simplify this kind of automation thanks to the webhook system. The webhook features allows you to trigger an HTTP call to a web application when an event occurs in Data Hub. Currently, we support multiple event types and will continue to add more to increase the flexibility of the platform. But for this case, we are going to leverage the create source event, which will, you guessed it, be triggered every time a source is created. Obviously, while the webhooks represent a very powerful feature of Data Hub, the only thing they can do is sending an HTTP post request with a fully customizable body. It would be possible to call the Things Network API directly using this method, but some mandatory parameters such as the different security keys would then have to be provided by the user when creating the source. If you're using an automated import process using the API or master data, this is feasible, but if the user is creating the source manually through the interface, it will be difficult for him to deal with those keys. For this reason, and for the purpose of this demonstration, we need an intermediate backend. I decided to use Azure Function, but the same principle applies to GCP functions or AWS Lambdas. Although, I wanted to use .NET Core and C#, and the integration with Azure Functions is far easier for me. Let's create the webhook. You can go to the account settings and then to the webhook tab. Then you can click Add Webhook and give a simple name. In the event type, you should select source create. In the webhook URL, we are now going to type something fake. Because we don't have the URL of the Azure function just now. We don't need an authentication mechanism for this case, and no custom headers. For the format, we are going to use JSON. And for this demonstration, we will need 4 basic properties. The ID, and you can get the ID straight away by clicking those little tabs there. We're also going to need the name, so that's going to be the name of the source. Same thing, we can click the name. Then we will use the serial number of the source. There it is. And we are going to get the tags of the source, which will help us differentiate so we're going to need the tags of the source, which will help us differentiate between different kinds of sources. And this is where we are going to add the information that this is a source that needs an integration with the Things Network. So in this case, we use the keyword JSON, which is simply going to output the value of the source.tags. Oops, a small mistake. And this is going to create an array. We can click on the test button, which in this case is going to fail because the URL that we have used is definitely not an existing URL. But the important thing is to see what kind of information Data Hub is going to send in this case. So this is test content. Okay, so now that we are happy, we can save it and take a quick look at the API reference from the Things Network. We can see that we have methods to manage the applications. So you have manage, I see it's delete application, delete device, try down link, get application, get device, and the one we're actually the most interested in is a bit below. This is set device. So this one will allow us to create a device in the Things Network for our application. So as you can see, there's like a set of properties that we have to set on the object, and this is what I prepared for the demonstration. So I have a demo Azure function code where I implemented a service for the Things Network, and I made some tests with getting devices, and I also created one for create device. Now, if I look at the function itself, it receives the HTTP call whenever the source is created, and it will expect this this data, so the ID, the name, and the tags of the source that has been created. It's going to check if among the tags it can find TTN, and then creates the device on the Things network. To create the keys, I used a small function that is not very interesting, but it's a small function that creates hex keys, as this is what the Things network is expecting. Once the device has been created, we are going to use a patch command on the OpiSense API, and we are going to update 3 properties. I chose serial number, meter number, and localization, just for simplicity and not going through into the forms data. But we are going to use those 3 properties to store the dev EUI, the network session key, and the application session key. The dev EUI is actually stored in serial number, and this is what the trigger that we built earlier is expecting to do the matching between the data coming from the Things network and the source in Data Hub. To have the application working, we need to have a key. A key is very easy to get from the Things network. You simply need to go to your application. In the settings, you have access keys. You can generate a new access key. You need to give it a name. And you have to give it more access. And it needs to be able to edit the settings of the application and view and edit the device of the application. Generate the key, and then in the overview, if you scroll all the way down, you can see the key here. Well, it's just behind me, but it's right there. And then you can copy this key, go back to the code, and the key is located in the service right here. So I create my key, and now I can start working with the application. I already created an application in Azure Functions. So you can see that I created this application, which is for the moment empty. There's no function in it. But I did this because there's a few configurations that are needed, specifically for one library that we're using, which is the OpiSense client, which is going to help you contacting and interacting with the Data Hub API. But there's two information that we need to have in the settings here, which are the TTN app EUI and the TTN app ID. Those information can be found on the Things Network console. The app ID is basically the name that you gave to your application, and the EUI, you can use either of those. In this case, I chose this one. As you can see, if we show the 2 values that are here currently. Now I can go back to my code. I should be able to publish to Azure. I can use this one, which is the one we just saw. And if I click run, it should deploy the application to Azure Function and start the application straight away. Okay, now it's ready. We can go to the Azure function. If I click on functions now, it should pop the function that we have created. There we are. And if I go to the settings, I can see there is code plus test. And I can get the function URL. I can use, in this case, I can use the default key. Those are the keys to avoid anybody calling your API by mistake, and you can give different security level for your key. So there is like a master key that is allowed to call any function, and there is like a function default key that is only usable for this this function that we are currently working on. So I can take the URL, go back to the code. Oh no, sorry. Go back to Data Hub, and I can use this URL now. Save. Webhook saved successfully. Let's close this and enable it. Save. So we can see that now the webhook is ready. If I create a new source on my site, we're going to choose a custom source. Very important here, to simplify the demo, we need to give a name that is going to be compatible with the Things Network device ID. So basically it's alphanumerical. It can use dashes and underscores, but not to start or not to end. We're going to do device-test-001. In the tags, I need to say TTN, otherwise it's not going to be taken into account, and we are going to use generic data energy type because it's going to require it, and then we can scroll all the way to in the time zone to find the UTC. So now if I save, a webhook should have been sent to the Things Network. You can see now there's still no history, but I can refresh. There should be one now. Okay, it says succeed, which is a very good news. And I can see that this information was sent to my Azure function with this URL, and that the Azure function replied TTN device synced. If I go to the Things Network, go to the devices, we now have device test 001 that is created, ready to be used. And if I go back to Data Hub and I go to the sources, I can see my device test 001, and I can see that my serial number, meter number, and location have been updated with the necessary security keys that will be used to create and use the device. We can also have a look at the Azure function. If we go to the Monitor tab, we should see that it's been run once, and if we click it, you can see the logs that it's outputted. If in your Azure function you want to add more logs with the built-in logger, they will show up here, so it could also be useful to come here to troubleshoot in case of problems. To further improve the integration, we can also use the webhook event for source update and deletion. This way, you could update the device or even send it a downlink message to change its behavior, like, for example, change the frequency at which the device is sending data to the Things Network, or turn an external device on or off. You could also delete the device and make sure both platforms stay in sync. Now, in the case of an IoT solution, you might be willing to keep track of which device has already been deployed and is working properly. For this, I'm going to use the report feature of Data Hub. As you can see, I already created one report, which is devices to connect. If I open it, it's a very simple report. This should execute every Monday at 7 a.m. The data source consists simply of a view, a source view, where I listed all of the sources that have the TTN tag that we created earlier. And I included a few other metadata that are going to be necessary. This report is going to be sent to myself in a PDF attached to the email. And the last thing I have to do is to give the template that I created just for this. Let's select it. And voila. So we can save the report, and then we can run. Within a few seconds, I should receive in my inbox the report that should give me all of the devices that still needs to be connected to Data Hub. And there we go. Yeah. So you can see that there are two devices, because one of them, this one is a test I did before the video, and this one is the one that we created together. Okay, now let's talk about the next steps. In this example, I created a single source to show you how easy it was to use the two portals. But if you have lots of devices, you would be willing to look into master data. Master data is the Data Hub tools that create sites, source, and much more in bulk. We publish the full documentation in our documentation website in docs.opinum.com. Also, the OTAA protocol is definitely much simpler and secure, as the security keys are negotiated at every connection of the device to the network. The ABP protocol is there to support all devices and gateways like mine that are not fully compliant with the LoRa specifications. In my demo, I showed you that you can create a device yourself from an Arduino board. But there are lots of off-the-shelf devices and smart meters out there that are LoRa ready. You can head to the website of the Things Network to find out a list of certified devices and device suppliers. Finally, the trigger that I used in this demo only supports dictionary-like data and will not work if you use nested properties. Although Data Hub will still be able to process the data, but you'll have to contact our support in order to discuss the different possibilities. Thank you for joining this session, and don't hesitate to contact us for more info. Goodbye.